Python, NumPy, and SciPy libraries. There are two other commonly used math libraries in Python that can be used depending on what function is needed. NumPy is a library that provides a basis for working with matrices or arrays and allows for faster and easier manipulation of them. And SciPy is a library that provides tools for scientific methods to be used in Python programs. NumPy stands for Numerical Python and is pronounced NumPy. This library provides a basis for working with matrices or lists and allows for faster and easier manipulation of them. Python lists allow for the storage of datasets, but the NumPy library provides faster methods because it allows for the use of arrays. Unlike lists, arrays consume less memory and allow for arithmetic operations. Note, Python does not support arrays, so only when the NumPy library is imported can they be used. Like the math module, NumPy must be imported into the program as shown below. Import NumPy, or like this if using an alias. Import NumPy as NP. The NumPy library contains the ndarray object, which is a non-dimensional array and can be created using the array method. Below, the one-dimensional array R is created and outputted. Notice the square brackets, which contain the elements of the array separated by commas. Various types of ndarray objects can be created: one-dimensional, two-dimensional, and three-dimensional arrays. This can be done by separating each dimension with its own square brackets and adding a comma between them. So here we have a two-dimensional array. Once ndarray objects are created using the array method in the NumPy library, they can be sorted, searched, split, and sliced in addition to many other actions in order to perform what is needed. Through its many versatile uses, NumPy makes working with large datasets stored in arrays process faster. There's more information on additional functions in the NumPy documentation. SciPy stands for Scientific Python and is pronounced SciPy. The SciPy library builds on the NumPy library in that the arrays created using the NumPy library can be manipulated with SciPy functions. It varies slightly in its execution because it is broken down into a variety of subpackages that have pre-written methods that allow for different scientific functions to be used. SciPy requires that each of its subpackages be imported separately when the package is used within the program. The library is imported with the statement import SciPy. A similar variation is shown here using an alias. Import SciPy as SP. However, a call to import the specific subpackage you will be using is necessary with the following statement. From SciPy, import constants. Constants can be any subpackage, but in this situation we're importing the constants subpackage. We use the from keyword to determine which library to import from, so that's SciPy. Then we're going to import whatever specific subpackage within the library that will be used. So in this case, that's constants. Once we correctly import the SciPy library in the desired subpackage, we can quickly reference information as needed. In the program below, two well-known constants in math and science are called from the subpackage and printed. So we have import SciPy, from SciPy, import constants. Then we can save constants.py into the p variable, and that's going to have the value of pi. Constants.m_p is going to have the mass of a proton. A few examples of subpackages that are available in the SciPy library are constants, which we've already gone over. That has constants like pi, e, the mass of a proton, gravitational constant, etc. We have the special subpackage for special functions mostly used in mathematical physics, including factorials and trigonometric functions, and linalg for executing linear algebra functions like matrix operations. There are a variety of subpackages available in the SciPy library that can be found under its official documentation.